For example 6, we're finding a force. We have a cart here. It's on a slope that's a 30-degree incline, so it's on a hill. We're told the cart weighs 200 pounds, so the force of gravity is coming down. The force is going to be 200 pounds this way. We're called negative because it's pushing down. To put that in component form, this is the same thing as saying it's negative 200j, because j is up and down. Component form would be 0, comma, negative 200, and that is the force, or the gravity, so the vector F. Okay, our job is to find the vector, or how much force is needed along this vector. We'll call this one V, to keep it on the slope, keep it from rolling back. So how much force is needed to keep this from going back? Kind of like if I was a guy right here holding it up, how much force would I have to use to hold that wagon from rolling down the hill? Obviously without a block in there. Okay, we'll call that vector V. Well, since this is 30 degrees, the vector V is going to be equal to the, try that again, the cosine of theta I plus the sine of theta j, off the form of the reference sheet. This is the unit vector along the ramp. Okay, it's 30 degrees, so I'm going to put in 30, cosine of 30i plus sine of 30j. Cosine of 30 is square root of 3 over 2i. Sine of 30 is 1/2 j. Okay, then if I go to the unit vector form, square root of 3 over 2, comma 1/2. So this is the vector V, the vector V. And so what I have to do to find the force, or the W1, like I had in the last example, is this is going to be the projection of F, the force, onto the vector V, like that. And so it is going to be equal to, according to our formula we got from the last example, it's going to be F dot V over V squared times V. The projection of F, the force of the wagon, onto the vector V. Okay, so to find F dot V is the first step. So I'll find F dot V down here. Alright, remember F is 0, comma, negative 200. V is 3/2, comma, negative 1/2. So that's going to equal 0 times square root of 3 over 2 is 0, plus negative 200 times 1/2 is negative 100. So F dot V equals negative 100. So I'll put negative 100 in for F dot V. For V squared, the magnitude of V, it's going to be equal to, square root of 3 over 2 quantity squared plus 1/2 quantity squared. So we need some more space here. So that's going to be 3/4 plus 1/4 after I do the math, which is going to be square root of 1, which is just 1. And then 1 squared is still 1. And then times V of square root of 3 over 2, comma, 1/2. Well, this is the vector that's on. This is the vector it's on, square root of 3, comma, 1/2. This is the magnitude of that vector. So the force needed to keep this wagon on the hill is just going to be 100 pounds of force. So this dude here has got to be able to pull with 100 pounds of force to keep that wagon on the hill.